Hello dear viewers, today we are going to implement the linked list transversal and insertion. So let's start with the dev C++, new source file. So actually what we are going to do, we are going to create a node first, right? Okay, so our resulting program would be based on this node, right? Okay, so this would be our node. The first part would be the data part, and the second one would be the pointer, which is pointing to the same type of the node. So this was the basic thing we have to implement. So this would become our node. So this algorithm is to insert the node in linked list. Now first we are going to include some header files. Include standard input output.h, include standard library.h. That is for the dynamic memory allocation. Fine. For the dynamic memory allocation, for malloc. Okay, so this would be a int main. So this would be the basic layout of our program. Return 0. So now let's start to create a node. So to create a node, we need a two data type clubbed into the one unit. The one would be, let's take an integer. Let's suppose we want to store an integer in our linked list. So the first part would be the integer. It depends that what you are going to store in a linked list. It may be character, float, and whatever the data you want. But here we are going to consider that we are going to store an integer. So the first part would be the integer. Let's name it as a data part. And second would be the pointer. Fine, that would be the pointer. But of type the node. So this is our node. So let's create a node that is stuck. I'm going to use the structure stuck node. So that would be my structure. That would look like this. Fine. Okay. So now let's complete this. That part, pointer part. So in general, you are going to write star next, int star next, int star next. So this would be our pointer but of a integer type, but here we doesn't need an integer because this next would be point to some integer. But here in case I want this to point to the this another type of a node. So here I'm going to write stuck node. So this would be our data type, means this pointer, next pointer is going to point to this type. Right? So this is the creation of a node. Right? Okay. So now I'm going to cut this from here just to demonstrate that thing. So I can't replicate that thing. Okay. So now this pointer is going to point to a node. Oh, I should use a tab rather than space. Okay, never mind. Okay, so that would be my next node. Fine. Sorry for the bad graphics. Fine. Okay, so that would be my next node. So this is a node and this pointer is pointing to that node. But before that, we need a pointer. We can write it as a start. This would be the pointer which is going to point to the very first node. Fine, that would be our first node. Okay, so this is a start pointer that is going to point to this first node, fine, and then this node is going to point to the another node. Let's suppose this is the last node and that would be the null pointer, fine. But before that our the start pointer is pointing to null pointer if there is a no data inside it, fine. Okay, so now let's mimic this thing first. Here I'm going to create okay, that is the node, that is start. Let's put it a star. So start. So this is the pointer. This is only the pointer. There is no data part. Fine. So this is the pointer which is going to point to some node. Okay. So that is all of the basic of our linked list. So we have created a node data structure using a structure. If you are working in a C++, you can use the class for the same thing. That would be much easier. Okay. So now I want to add some node. So let's take a case one. I'm going to insert a node at the beginning of a linked list. Right? Okay. So here let's create a function void insert at the beginning of the node, and here I want to ask the user that which value they want to insert. So as our first part is the integer part, so here I'm going to take integer. Let's take a value, int value. So now from the main I'm going to call this function to insert something into our linked list. So our function is insert beginning. So this is a very layman structure. There is no that a graphical or a good interface. This is just an implementation of an algorithm, right? So at the beginning I want to insert 7. Okay, so that value, so this is a function, this value is going to be passed on to this function. 7 would be over here. So now I'm going to work with 7 over here. So now here what we are going to do, so first in our list, so this is my start pointer pointing to the null. Here according to the algorithm we are having, so this is a start, we are having a avail list, fine, avail list. But here actually we doesn't want to work with a avail list, because we are going to now implement that thing in a C++. So here we are going to use a malloc or calloc function. Okay, so here we are going to use malloc or calloc function instead of avail. Okay, so now this is the program specified, right? Here first we are going to create a node. Let's create a node with this malloc function. I'm going to create a node over here. Okay, so now we are going to work with that node. So this is the very first step. Let's create the space for this node. So that would be our first step. Then we are going to put the data over here, fine, and then the updation of our pointer would be there. So here the first I'm going to create a node of a type that would be struct node, that would be the pointer. Let's take it as a temp. This is a temp, that struct node that is equal to temp. Now we have have this pointer. Now we are going to create a memory with a malloc. Malloc will have only one function, that is a size. Now that would be the size of what? This whole thing, fine. Size of struct node, whatever the data is going to occupy with this structure. So malloc will return you a null pointer. So we are going to struct star. Fine, because this is a null pointer. This malloc will return a null pointer, but we need a memory allocation of type star temp, which is of a struct node type. So here the struct node pointer would be specified, that the whatever the null pointer is null address is returned by the malloc, that is the type casted into the corresponding this one. So we have here created a node. Fine. So now here temp of data. So I am going to assign a data to the temp variable. Fine. Temp data. So here val, as 7 is passed to this val, so the val would be my data in that node. And now temp next, that is equal to what? That would be start. Okay, so this is our start. Okay, so what basically we did over here, so this would be the node created by the malloc. We have put val over here. Fine. And here we are having a start pointer that is pointing to the null. Here now what the operation we are going to perform over here, that would pick like this. Now start is pointing to the null. So now where start is pointing, this thing is going to be okay, I should press OK. So where start is pointing, this thing is going to be point to that particular thing. So why is it so? Let's take a second scenario. Let's suppose start is already having some data. Fine, this is a node. Let's suppose this is the first node. In that particular case, this pointer is pointing to this node. Fine, that would be our first step. And in a second step, this start pointer would be going to be updated to this node. Fine. So now our resulting path would look like this. So this is our path. So this thing we are going to implement now. So now here temp next is equal to start. This thing I already stated over here. So now this is our temp. Temp next would be equal to the start, where start is pointing. Fine. So now the next thing is start equals to temp. Fine. The start is going to be pointing to the temp. That's it. So first and second part simple. So now here, now start is going to be updated to the temp. Start is going to point to the temp. Fine. Okay. So that is all that we have inserted something into the linked list, and you can call this function as many times as you want. Let's suppose now I want to insert 1 after 7. So now we have to show each and every element in a linked list, or you can say this is a simple transversal of a linked list. So how we are going to implement that? Okay, so we are going to implement that by creating one more function. Let's take it as a show. Okay, so here what we are going to implement, we already having this linked list. Fine. So this is the linked list. This is a start pointer. Fine. Okay, so let's take this scenario. We are having a 2 element over here. Start is pointing to this one. Fine. So this is our scenario over here. So now we are going to implement that. We are going to traverse each element at once, right? So we are going to start with the start pointer. If that pointer is not pointing to the null, then we are going to print this data, fine, and then update the pointer. If again that is not equal to null, print the data, then again update the pointer. So now this time this is a null. We are going to stop our traversal over here. So this is the scenario we are going to implement over here. Okay, so for that we are going to create a pointer white show. Okay, so here I'm going to create a pointer. Let's create that pointer with the name ptr. So this is our pointer, and I'm going to assign start. So this pointer is pointing to the very starting of that node. While, okay, let me, okay, while ptr is not equal to null. Okay, I just missed something. The first time this start, if I hadn't assigned anything to the start, that would be a wild pointer, right? So here you are going to put null over here, right? First time the start is equal to null, then when you are going to insert something, then your first node would be whatever you have inserted, and that is going to point to the last node is going to point to the null. Okay, while pointer is not equal to null, what we are going to implement over here is that ptr data. So this thing we are going to print, right? So here we are going to write printf. So our data is of type %d, comma. Okay, so put some spaces so that you can distinguish between the values. ptr data, fine, that's all. So okay, we are going to print that thing. Okay, print while point. Okay, now we are going to update the pointer ptr next. So our ptr that is equal to pointer next, where pointer is pointing. Now pointer next, now this pointer is pointing to that next particular thing. Okay, so now I hope we have implemented that thing. Now we are going to do what? We are going to show, calling a show function. So let's execute our program. Linked list basic insertion, linked insertion at the beginning. Save. Okay, so here's we are having something invalid preprocessor. Okay, with this header file you can't use a comment. I think that would be the possible reason for the error. Okay, std. Okay, I forward put this angular bracket. Okay, let's go for it. Okay, so okay, big mistake. So this is not a function definition, function declaration. So this is a function definition. The semicolon would be there. Okay, you can see 1 and 7 is on my screen. Okay, first I just enter 7. Fine. So I'm going to insert at the beginning. Next time I'm having a 1 in front of that. So that's why it's a 1 7. So this was the very simple implementation of insertion at the beginning of a linked list. In the next lecture we are going to use some another variant. We are going to elaborate this program. Until then, if you like this video, just press a bell icon so that you can have updates regarding my new videos, and please subscribe to my channel if you find this work useful. Thanks.